Alright, so now let's look at scatter plots. Scatter plots. Now, of course, we've spoken about scatter plots already. Scatter plots. That's the second to the last. Now, scatter plots are just plots that help us to check whether there is a very, very good relationship between any two numerical quantities, such as this data, we have age, we have average score, we have the essay score, we have the video score, all those are numerical features. Right? So scatter plots help us to visually see that once we plot these values, we can be able to easily see uh, whether there's any relationship between them. I mean, any significant relationship between them, right? And also the direction of the relationship. So we've seen that about scatter plots. Of course, you can go back through the previous video like I spoke about and check. Let me just put this up and use a minute to try to explain what scatter plots are so that we can be able to consider some things. Now that you can see, this is a perfect scatter plot, right? And this is a scatter plot between the variable and itself. It's a perfect correlation, as you can see from here to here. Now here it's also showing us not a very, very strong relationship, or yeah, it's at least it's encouraging, and you can see the direction is going like this, right? This is also showing us a good relationship. Basically, these relationships are good, right? This one is perfect. You can see how it is in a straight line. Now you see this Oga here. This Oga is already looking scattered. The further the values are away from themselves, the weaker the relationship. So this is also a bit strong. This is also very, very weak. Right? So these are scatter plots. And of course, we're going to see them. It makes more sense when we now begin to calculate the correlation coefficient, which we're going to see when we go to heat maps. But let's just, for now, let's plot our scatter plots and be able to interpret a couple of them. You can check out one or two more tutorials on scatter plots. When you come back for your data science course, we're going to do more about interpreting all of these scatter plots and making more decisions on them. But for now, let's see scatter plots. Now for matplotlib, it's just plt.scatter. It's like this, and then you pass in your x and your y. Your x, let's try to see if there's any relationship between the age of people and their score. Right? We're just exploring the data. Age then y is equal to cos the average score. Let's see what this gives us. Now you can see this relationship is very weak. You can even see the direction. It's strong when it's lying down on an angle of 45 degrees. It's very, very strong. But once it begins to rise up, as you go anti-clockwise around 90 degrees, the relationship is showing you very, very weak relationship. And once it lies down like this, it's showing you a strong negative correlation. Once it lies down like this, at an angle of 90 plus 45 degrees, 135, an angle of 135 degrees. If you don't understand what I'm saying, just don't bother. But for those who do, this is invaluable information already. So when we have our plt.show, so that we don't have all of this extra noise that we're having here. Now, this is for you to see between age. You can explore between, let's say, video score. Let's see if the people that have more video scores actually had, you know, if there's actually a relationship between having a higher video score and having a higher average score, which is actually some kind of a strong relationship, as you can see. No, yeah, I'm not going to say not very, very strong, but it's a strong relationship and it's in the positive direction. And it's the higher your video score, the higher the chances that your score is going to be high, right? Or you can also see that there are some whose, yeah, of course, you can see the lower the video score, also the lower the average score, right? So let's plot in our other thing so that we can see plt.title. This is so I'll just allow AI to do it for me. Of course, X label is video score, Y label is this, so that it makes more sense now. Now you can see this is the video score and this is the average score. So the higher the video score, the higher that the tendency that you're going to get a good average score. This is a good relationship plot, right? And of course, let's see what our Seaborn can give us. I like Seaborn. can also just go ahead and type scatter plots. This your data is equal to df, and then your x of course is equal to the, let's start with the age, just like we did. Let's also check average. Let's do this. Okay, I think I missed something. Position argument. Okay, y. This is y. Right. Then we have this. Now you can see it looks similar to what we had earlier. Right, very, very similar. And if I change this one now to video score, we're trying to check whether this actually has a good relationship. Of course, you can see this is the same thing to what we have here. The same. The only thing is that the sizes of the dots here are relatively larger than the sizes of the dots. That's not the problem. Of course, you can change, you can use plt.figure to elongate this guy. So you, that is if you want. Okay, let's see what elongating this guy gives, but let us also add plt.title and the rest. Okay, so let's do this video score versus average score, right? And we have now, you can see, has helped us to avoid some overlappings, right? So the more the space you have, the less the overlapping, and this gives us this. Now, another great thing about SNS is that it gives you, it allows you to, you can color, you can do this by, let's say, gender, by using the hue argument. Gender, do this. You can see whether there is any relationship between gender, right? You can see it's just scattered all about. So there is nothing like the males have higher scores than the females. Maybe if you do a hist plot of average score or something, you're going to see that. But according to this scatter plot now, it's just all over the place. The colors are just mixed together. Now, what did we decide to use admission type? Because there are people who will give admission based on merit, and there are people who will give admission based on condition, like conditional admission. Now, look at them. Look at this now. This guy has perfectly separated these guys now. Now you can see that the people in cases where we have you can see all of these guys now with the red are those who gave them admission on condition, right? These guys now are the ones we gave on merit. Now if you look at it quite carefully, you find out that there is nobody who is conditional unconditional that is here. So this is showing us that more people that got a higher video score and of course consequently got a higher average score, were given admission based on merit. And you can see that this line itself of average score equal to 15 has separated all of them. And so why am I saying this? That's because we use 15 as the threshold. As if you remember the email. Okay. So sorry, the email we sent to them, we use 15 as a threshold for them. So why am I bothering us with all of this? I'm trying to make us see data in a different way, really, right? That this data that we analyze actually is very, very powerful, and you can easily be able to see this. Now, if the computer wants to predict people who are likely going to be selected and the people who are not going to be selected, by using this data now, you can easily be able to predict, right? So that's that about that. Now, the last thing I want to show you about Seaborn, it's very, very powerful. That is that you can pass in, you can do a KDE plot, right? But if you do a KDE, you can't pass in a hue. Let's do KDE. Sorry, not KDE, rather. Reg plot. You can do a reg plot. So instead of a scatter plot, okay, let me leave this hue, let's do this. So I'll just copy this guy, take it to the next cell, and run it there. So here we're going to have let's try scatter. Okay, sorry, let's plot. This is a regression plot now. So it will give us the same scatter plot, but this time around now with a regression line. And what we call a regression line is a line that is what we call line of best fit. For people who are into statistics, they understand line of best fit. That is a line that is going to easily be able to provide a way for us to be able to predict these numbers. For example, now in physics, I don't know if all of us did physics, but in the lab of physics, when you have several experiments, of course, they don't expect that the values will fall on the same line, right? So they ask you to choose some few points, and then you just draw your line through them. That is what we call the line of best fit, right? Because the line has to make sure that the good number of points are above it and the good number of points are also below. But the one perfect thing about line of best fit is that it tries to make sure that it is fair to every value, right? It is fair because each and every value now that is not on this point now, if you want to compute, if you want to predict it, for example, if I want to use the video score now to predict the average score, if I use 15 now, you can see here. So I'm predicting that the average score is around 17, let me call it 17 or 16.5. That's what I'm predicting. That the average score is going to be 16.5. So, but for all those good video scores around 15, right? You can see that their scores are around 18, 19, right? So one thing is that there are errors. So this line tries to find a way to offend everybody. I won't say equally, but to minimize the error. I'm trying as much as possible not to use machine learning concepts, right? So this is what we call the line of best fit or regression line. So it plots that, and it's beautiful. You get to see how your line is, and this helps you now to determine whether this is a strong relationship or a weak relationship. So from how this line now is plotted, we know that this is a very strong relationship, right? Maybe around 0.8 when we calculate the correlation coefficient in the next video. And of course, the last one now is the plotly. And as you can get px dot what scatter as well, not scatter plot. This time around, we go to with our data frame is equal to what? df. And our x is going to be our, say, video score. Okay. So we do this. It has given us the title, and it has also colored it for us, just like we have there. Basically, just the same thing, right? So if you want to see the distribution of only people who passed by merit, you turn off conditional so that you see only people who passed by merit, right? And if you want to see only people who pass conditionally, you can now do this. Then you can see the plot. Right? So you can already guess that I'm more fond of using this plotly visual. Right? So that's all about scatter plots. Of course, there is more to them. Of course, we'll see them subsequently, but for now, that's all about them. See you in the next tutorial.